In this video, I would like to talk to you about a method of reasoning that we call proof by contradiction in mathematics and in logic. Suppose that you have a statement. Let's say we have statement, we'll need to call it something. Let's call it P. Statement P is either true or false, T or F. We have a statement that is either true or false, and you want to prove that P is true. Okay, one way to do it is this. It has this structure. Suppose not. In other words, suppose P is false. Then on the basis of that assumption, you make a series of deductive steps and end with something completely absurd. Suppose not. Then you have a series of arguments based on your assumption. Based on your assumption that the statement is false, and you deduce something that is impossible. Or in other words, you contradict a known fact. Well, if you contradict a known fact and you have had a series of arguments based on your supposition, then your supposition must not have been correct. So you can conclude that your assumption was incorrect. Therefore, the statement P is indeed true. This is the basic outline of a proof by contradiction. So now we'll use a proof by contradiction to prove something in mathematics. Let's prove that the square root of 2 is an irrational number. Square root of 2 is irrational. Now you've seen this proof done in the book, but I think you might like this method a little bit better because it involves fewer A's, B's, C's, and D's. So let's give it a try. Well, we want to prove that the square root of 2 is irrational, so we will start by supposing not. Suppose not. Well, if the square root of 2, now we want to make some statements here based on this supposition. If the square root of 2 is not irrational, then the square root of 2 is rational. We don't want to make any missteps in our reasoning because all of these steps have to be made on sound reasoning, and we end with a contradiction. And the only thing that could be wrong then is the supposition. So then the square root of 2 is rational. Well, what does it mean if the square root of 2 is rational? It means that the square root of 2 is the quotient of two natural numbers where b is not 0. So we could say the square root of 2 is a over b, where a and b are natural numbers, and b is not 0. That's what it means to be rational. Here is where you have to remember what you've learned before. What does rational mean? It means that the number could be written as the quotient of two integers. Well, now let's multiply both sides by b and make a few algebraic steps here. Let's square both sides. let's square both sides first. You could do either, but if those two numbers are the same, then if we square both sides, we still have equals here. And that would tell us that 2, square root of 2 squared is 2, is equal to a squared over b squared. And now let's multiply both sides by b squared, so we have 2 times b squared is equal to a squared. So we know that if the square root of 2 is rational, then it is the quotient of two natural numbers, a and b, and that 2 times b squared is equal to a squared. Okay, so we have 2b squared equals a squared, and now we're going to see, could this really be true if b and a are natural numbers? And we're going to think back to section 2.3 when we learned that every natural number other than 1 is either a prime number itself or it can be prime factored in exactly one way. We also learned that perfect squares, each prime factor of a perfect square, occurs an even number of times in its prime factorization. So let's look here. Look on the right-hand side. I'll call it RHS. The right-hand side is a perfect square. The RHS is a perfect square. So there is an even number of every prime factor on the right-hand side. Namely, 2 occurs an even number of times. Two occurs an even number of times in a squared because a squared is a perfect square. Okay, well, b squared is a perfect square. So 2 occurs an even number of times in the prime factorization. I'll just put PF of b squared. Remember, if it didn't occur at all, then it occurs 0 number of times, and that's an even number too. So regardless of what b is, 2 being a prime occurs an even number of times in its prime factorization. But if that's true, then if we write 2b squared in 2b squared, how many prime factors do we have? If b squared has an even number and we put one more in, we multiply by one more factor of 2, in 2b squared, there is an odd number of 2's. So if on the right-hand side we have an even number of 2's here, and on the left-hand side we have an odd number of 2's, why can that absolutely not be the case? This is a contradiction to the unique prime factorization theorem. So I guess we need to go to another page here. Let's write out the contradiction that we have found. There cannot be an even number of prime factors of 2 on the right-hand side and an odd number of prime factors of 2 on the left-hand side, because this would contradict the uniqueness of prime factorization. Therefore, our assumption that the square root of 2 is rational is not correct. We conclude the square root of 2 is indeed irrational. So you'll have a homework problem like this assigned to prove that the square root of some other number is irrational, and you could use the method used in the book, or you can use this method here. You can assume that it is rational and then contradict the unique factorization theorem.